Okay, so we have the circle, x minus 3 squared plus y minus 2 squared equals 25. The center is at 3, 2, and the radius is 5. The circle's graphed below. We want to first draw a line tangent to this circle at the point 7, 5. So I'm going to go to 7, 5. So we are going to draw our tangent line so that the tangent line is perpendicular to our radius. That's one of our properties. When you have a tangent line, it will always be perpendicular to the radius of your circle. So I'm going to connect that point that's on the edge of the circle to the center, and that is my radius. So my tangent line will then be perpendicular to that radius. So that's a little visualization, but I just kind of eyeballed that. So we're actually going to calculate it precisely. The slope of our tangent line and the slope of our radius should be opposite reciprocals of each other, since those two lines are going to be perpendicular. So our center, which is at 3, 2, and that point that we're going to draw the tangent line through is at 7, 5. We mean the slope of the radius. So the slope of the radius is going to be 5 minus 2 over 7 minus 3, which is 3 over 4. Which means the slope of our tangent line is going to be the opposite reciprocal of that, negative 4 over 3. Because the tangent line and the radius have to be perpendicular. They have to create a right angle, and so therefore the slopes have to be opposite reciprocals. So now I can write the equation of the tangent line that goes through our point that has a slope of negative 4 over 3. So I will plug the point into point slope form. Y minus 5 equals negative 4 over 3, x minus 7. It doesn't specify if I need to put it in slope-intercept form. I'm just going to go graph it. If my slope is negative 4, 3, I'm going to start at my point 7, 5, and I'm going to go down 4 units and then to the right 3. So I'm going to start at that point and go down 1, 2, 3, 4 over 1, 2, 3. It's off the grid. That's okay. And then I'm going to go in the opposite direction. I'll go up 4, 1, 2, 3, 4 over 3, 1, 2, 3. And so now I can connect those points. And here is the tangent line. It creates a right angle with my radius. And here's the equation in point slope form. The next question is the line negative 3/4 x minus 7 over 4, is that actually a tangent line to our circle at the point negative 1, negative 1? So I'm going to go plot the point negative 1, negative 1. Here's our center. And we're trying to decide, is this actually a tangent line? Well, remember, the slope of our radius needs to be the opposite reciprocal of the slope of the tangent line, because the radius and the tangent line are perpendicular. So since the slope of that tangent line is negative 3 over 4, that means the slope of our radius is going to need to be positive 4 over 3, because our radius and our tangent line are going to have to be opposite reciprocals. So I am just going to calculate the slope of the radius, the slope that goes from the center to that point of tangency. My center, remember, is at 3, 2, and my point is at negative 1, negative 1. So the slope of the radius is going to be 2 minus negative 1 over 3 minus negative 1, which is 3 over 4, which 3 over 4 is not the opposite reciprocal of negative 3 over 4. And so therefore the answer is no, because the slopes of the radius, the slope of the radius and the tangent line aren't opposite reciprocals of each other. the tangent and the radius are not perpendicular because their slopes are not opposite reciprocals. The opposite reciprocal of -3/4 should be 4/3. The slope of that radius should be 4/3 if that line is indeed tangent to the circle at that point. Finally, we give you the actual equation of the tangent line, and we're trying to decide we're trying to decide where that line is going to intersect the circle. What is the point of tangency? So we have done this before. We have two different equations. We have an equation of a line and we have an equation of a circle. So we can solve our system of equations. We're going to plug this right side of the equation into the circle equation for y. So we're going to, step one, plug the line equation into the circle equation. We're going to do some substitution. So I'll have x minus 3 squared plus, instead of y, I'm going to have 3/4 x plus 6 minus 2 squared equals 25. I'm going to need to clean that up, combine some like terms. And now I'm going to need to FOIL both of these. So x minus 3 times x minus 3 is x squared minus 6x plus 9. And when you FOIL 3/4 x plus 4 squared, you're going to get 9/16 x squared. 3/4 times 12 is 3, so plus 6x plus 16 equals 25. If you notice, the positive 6x and negative 6x are going to cancel each other out. We're going to combine some like terms. 1 is 16/16, so common denominator, combine those, and you're going to get 25/16 x squared. 9 plus 16 is 25 equals 25. And so if you subtract 25 from both sides, those cancel out, and so you'll get 25/16 x squared equals 0. Then you can just divide off that fraction. You get x squared equals 0, and then if you take the square root of 0, you get 0. And so to get our y coordinate, we didn't even have to do the quadratic equation or anything like that. Our quadratic ended up being nice and pretty, but remember, if you ended up with a quadratic and you couldn't factor it and you need to solve for x, you could plug a, b, and c into the quadratic formula. But now I have my x value. I just have 1 point because that makes sense. We have a tangent line, and a tangent line is only going to intersect our circle in 1 point. This is not like the other problems where our lines intersected our circle in 2 places. This is a tangent line. It's only going to intersect the circle at 1 point. So that makes sense why we only have one solution to this quadratic. To get the y coordinate, though, we're going to take our x value and we're going to plug it back into x in the line equation. That's going to be the easiest way. Y equals 3/4 times 0 plus 6. Y equals 6. And so the point of tangency is going to be 0, 6. So if we were to go graph that line, though, that would make sense. So the y-intercept of that line is at positive 6. And if you plot the line, you'll go up 3/4 and down 3 to the left 4. So then we can graph that tangent line and confirm it with our radius. If you count from this point of tangency to the center, you're going to go down 1, 2, 3, 4, and then over 1, 2, 3. So that means that our radius has a slope of -4/3. And if we check the slope of our line, our tangent line has a slope of +3/4, +3/4, and -4/3 are opposite reciprocals. That makes sense because our tangent line and our radius should be perpendicular. They need to create a right angle. Those slopes should be opposite reciprocals of each other, and they are.